me 5 minutes, let others join, then we can start the session. Is there any doubt? Do you want to ask or something?
Good evening, ma'am.
Okay, let me share my screen. Is my screen visible?
Yes, ma'am. Ma'am, so today we will do question practice of
Yes.
circuit questions.
Yes. Question practice because you have quiz in the last week of this month.
Yes, ma'am. Yes,
So,
ma'am.
so we can do more question solving so that it will be easy for you to do the solve questions in the exam. So,
Okay, ma'am.
I think organized all these things, the topic summary and all, right?
Okay, ma'am.
So let's do more questions. But before going to that, like this question we have solved last time. So everyone got the answer minus 3.27 volt. So by applying the KCL or KVL, those concepts, I wanted to say something new like a voltage divider rule. Do you know voltage divider rule? If a subcircuit is given, how the voltage divider rule you should apply. Do you know? Anyone can answer? Do you have the idea about voltage divider rule or not? Because last time we have solved this question by using KCL and KVL. So I wanted to solve this question voltage divider rule. So which will be giving you answer in 2 steps. That's why I wanted to introduce this concept. So anyone knows about that? Let me know. Am I audible?
Yes, ma'am.
Yes, ma'am. You are audible.
So can you tell me, do you know about this rule or not?
No,
So
ma'am.
No,
I
ma'am.
should get no. Okay. So this is one of the means like concept. In this circuit we can apply, and in 2 steps we can get the answer. How we can apply that we can see later. First, let me discuss about that. What is voltage divider rule? So in case of if you have one voltage source plus minus, let me say that V1 is there, and if you have multiple resistances connected. Let me tell you only one or two resistors by taking. This is R1, this is R2. So whenever you have studied about that series circuit and parallel circuit of the resistors, what did you get this knowledge? Whenever resistors are connected in series, voltage gets divided. When the resistors are connected in parallel, currents gets divided, right?
Yes,
Am
ma'am.
I right? Okay. So here these two resistors are connected in series.
Parallel.
That means series or parallel. How to know
Ma'am,
that these are connected series or parallel?
ma'am, 4 ohm, 8 ohm, or 8 ohm and 12 ohm.
No, not this right side I'm showing in the green color I'm writing, right?
Acha, that is in series, ma'am.
This is in series. R1 and R2 are in series. So this voltage V1 will be divided among the R1 and R2, right? If I apply the KVL here, if I apply, so I can write, means for example, current I is flowing through this. So I can write plus minus, plus minus. This is VR1. This is VR2. So I can, if I apply KVL, I can write minus V1 plus IR1 plus IR2 is equals to 0. Am I right? So here I can write this is nothing but minus V1 plus I can take as common R1 plus R2 is equals to 0. So if I wants to write this I R1 plus R2 is equals to V1. Can I write? Can I write this one?
Yes. Yes.
Okay. So this I can write also I is equals to V1 by R1 plus R2. Is it? So I got the current across this,
Yes, ma'am.
right?
Yes.
So if I want to find out VR1, VR1 is what? Tell me, VR1 is nothing but voltage drop across the resistance R1. That will be nothing but I into R1. Am I right? Is it or
Yes,
not?
ma'am. Yes, ma'am.
So if I substitute this equation 1, let me call it. This is equation 1. If I substitute equation 1 in equation 2, then this equation 2 can be written as VR1 is equals to I is what? V1 over R1 plus R2. This is multiplied with R1. Can I write this? This equation 3, let me call. Is it fine for everyone? How I have written this VR1? Is it fine for everyone?
Yes,
Yes.
ma'am.
Similarly, if I want to write VR2, VR2 is equals to I into R2. So I can replace I again with V1 over R1 plus R2, which is multiplied with the R2. Let me little bit what's this one? Yeah. Yeah. So is it visible to everyone? This part, green color, whatever I have written, or shall
Yes,
I
ma'am.
again enlarge a little bit, or is it visible?
Ma'am, it's
Please
visible.
for a little bit enlarge.
Okay. I wanted to show the circuit and equation together. That's why I'm doing this. So you see here, this is the V1, right? And this is VR1 is the voltage across R1, VR2 is the voltage across R2. So now you are getting I is equals to V1 over R1 plus R2 means total current flows in this series circuit. So whenever we have written, and we know that in the series circuit, total voltage gets divided among the resistors. As per our knowledge before, in the series and parallel circuit, we have studied, right? Fine
Yes,
with
ma'am.
everyone? Okay. Now come here. So in equation 3, we are writing voltage across R1 is VR1, which is nothing but V1. V1 is the total voltage. This V1 is the total voltage divided by R1 plus R2 multiplied with R1. That means R1 is the resistance across the R1 only we are finding the voltage. So that means we can say that total voltage multiplied with the resistance across the resistance, which resistance we are finding the voltage divided by total resistance. This is R1 plus R2 is nothing but total resistance present in the circuit. And R1 is nothing but voltage across R1. We need to find it out. That means we can say that total voltage is getting divided. Okay. Is it fine?
Yes, ma'am.
So that's why it is known as your voltage divider rule. Means total voltage is getting divided among the R1 and R2, and the formula how to means this is nothing but formula we derived. Like total voltage gets divided across R1 and R2. The formula is if we are finding the voltage across R1, total voltage multiplied with the corresponding resistance divided by total resistance. This is the formula you have to remember. And how it is derived, you already got it.
Yes, ma'am.
Okay, fine. So now I wanted to use this concept in this circuit to find it out so that it will be solved in the 2 steps. So can you try? So for example, how can we here only 2 resistance and series, you have multiple resistance. How can you know that like total voltage is getting divided? So simply we can say that this 6 volt is divided among 4 ohm and this total resistance here. This total resistance is what? 8 ohm parallel to 12 ohm. Is it fine? So can I reduce this circuit? This circuit is equivalent to, I can write here, this is 4 ohm. This is 6 volt. This is 4 ohm. This is 8 ohm parallel to 12 ohm. Am I right? So this circuit is equivalent to this circuit. Is it or not? Can you apply the voltage divider rule to find out V4 ohm is how much and V 8 ohm parallel to 12 ohm will give how much? Tell me the answer quickly. Tell me the answer quickly. 8 ohm parallel to 12 ohm, how much it will give?
96/20.
Pardon?
96/20.
96? Yeah. 96 by 20. It will give you how much?
4.8 ohm.
Yeah. So it will be 4.8 ohm. Okay. So now you apply your uh, voltage divider rule and tell me what is the value of this V4 ohm and V4.8 ohm. Tell me. You just calculate and tell me.
Current across 4 ohm and 4.8 ohm. Ma'am, 24 ampere and 28.8 ampere.
So can you tell me how much you got it? Voltage across 4.8 ohm and voltage across 4 ohm. Anyone got it?
Ma'am, 24 and 28.8.
So here you got it. How did you means apply this formula? Can you tell me?
V is equals to IR.
No, I asked you to apply this formula.
Okay.
This formula. Okay. So that means total voltage gets divided across the 4 ohm and 4.8 ohm. Are you following everyone or not? What is I'm doing? This applying the KVL, KCL, you have already solved this question in the last session. Today I have told you the voltage divider rule, how the voltage gets divided among two resistors if it is in parallel, if it is in series. So how can we apply here? So total voltage is how much here? Minus 6 volt, right?
Yes.
This is minus 6 volt. Multiplied with minus 6 volt, multiplied with, I'm going to calculate the voltage across 4 ohm. That means that resistance I have to multiply divided by
So
total resistance.
4 plus
4 plus
8 ohm.
4.8 ohm,
4,
right?
8 ohm.
Then how much is it giving?
2.8.
Yes.
6 is multiple with 4 only or with both.
No. That is the formula we derived here. You see, total voltage multiplied with the corresponding resistors.
Okay.
Ma'am, I have got
Which registers across you are finding the voltage.
Okay.
Ma'am, I have got around 4 ohmic resistance. The voltage is 2.72 and around 4.8 ohmic resistance is 3.27.
4.8.
No, ma'am. Yeah. At 4 ohmic
So,
resistance is the 2.72 voltage.
Yes, good. But that is minus 2.7 because here minus 6 volt. The total voltage
Yeah.
source is value is minus 6 volt. So minus 2.72 you will be getting. So see, again, I am saying the voltage I am finding across the resistor 1 is nothing but total voltage multiplied with the resistance value of the resistor 1 divided by total resistance. Similarly, I am doing here, I am finding voltage across 4 ohm. Total voltage is minus 6 volt because this is minus 6 volt source. Shorter battery means length is here means oxide means this is minus 6 volt. If you reverse it, that will be plus 6 volt. So minus 6 volt multiplied with the corresponding resistance is 4 ohm divided by total resistance means 4 plus 4.8, right? So then I can get here the value will be minus 2.72 volt. Did everyone got it? Everyone got this?
Yes, ma'am.
Nitish got it. Anyone else?
Yes, ma'am, I got it. But I have a doubt with regard to the convention of the voltage side.
Pardon? Can you repeat?
Voltage side. How do we get to minus?
Okay, minus how to? This if you're writing, this is your battery. If it is written 6 volt means this value is minus 6 volt. If your battery is like this, if it is given 6 volt like this means it will be plus 6 volt. Right now your battery is in this way, in this form. Is it or not?
That means current
That,
is flowing from
that means
positive, negative.
that means this total voltage value whenever we will substitute, that will be minus 6 volt. This one.
Yes, ma'am. When the
And
current
ma'am,
is
we had to
flowing
multiply
from
total voltage into the. We are finding the
Voltage across which resistance we
which
are
resistor.
substituting. That resistance divided by total resistance. Similarly,
Okay.
4. Whenever you do minus 6 multiplied with 4.8 divided by 4 plus 4.8. So how much will get?
Ma'am, minus means voltage drop from plus to positive to negative side.
Here the minus, your source was minus 6 volt. That's why you're getting minus 2.72 volt. This drop you got it at the 4 ohm resistance minus 2.72 volt. If you add two voltages, then you will get minus 6 volt. Are you following?
Can we say with regard to direction from positive direction to negative direction, so it is minus? Can we say
Can you repeat your question again?
when the current is flowing from positive direction to negative direction, the law.
Positive direction to negative direction. See, due to minus 6 volt, some current will flow here. But
Yeah.
this current will flow from plus to minus. Because why? According to the Ohm's law, whenever current enters, we used to assume because there is no polarity of the resistance. But because of this current flows, we used to say that it used to create the potential difference from positive to negative. That will be your V4 ohm. And this V4 ohm is equals to minus 2.72 volt you are getting, means you can understand that like here the voltage drop whatever you are getting negative because your minus 6 volt is the supply voltage. That's why drop is also in the negative form.
Okay, ma'am. Thank
Any other doubt?
Ma'am, what you explained here about the negative voltage, 6 volt and minus 6 volt, it's like a orientation of the battery. So let's suppose I have a battery or a cell of 6 volt,
Yes.
and suddenly I
Yes.
rotate 180-degree, then it's a produce negative voltage. So it makes
Yes.
sense.
Yes. 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 So whatever you were getting the values here, the values will be opposite. Okay. You can check in the multimeter also. So right now, if you add this minus 2.72 plus minus 3.27, it will come approximately minus 6 volt, right? Okay. So this is nothing but by directly means now our main focus was that like to find out the voltage across this two end like V naught. V naught is how much you need to find out, right? The question was that you need to find out V naught. V naught is nothing but same as the voltage across 4.8 ohm. Can we say like this? If I'm saying this is my A, this is B, this is C, and this is D. So A to B, C to D, the voltage drop will same, and that is nothing
Yes.
but is equals to V naught. That is nothing but equals to V naught, right?
Yes.
So A to B and C to D, whenever they are in parallel, that means they have same resistance, that is 4.8. So whatever we are getting V 4.8 is nothing but equals to V naught, we can say. Is it clear?
Yes. Yes.
So how many steps it took to solve the question? 2 steps only. But if you see the previous sessions, we have done the same problem. We have done 5-6 lines of means equation solving then only. So this is the shortest method to solve this question. Just I wanted to tell you, so that's why I have discussed this method. Is it clear for everyone, or any doubt is there?
Ma'am, clear.
Okay. Can I go for the next question? Okay. So the next question is, this question I had given you as homework. So who can has done this? Can you tell me? This I have given you as homework. Anyone has solved? If it is not, then solve it right now and tell me what is the value of I1 and I2.
Okay, ma'am, just solving.
Yeah. Did you get the answer?
Yes, ma'am.
Tell me.
Ma'am, I1
Ma'am,
will be 6 amperes and I2 will be 4 amperes.
So anyone else?
ma'am, is I1 4.67
Okay.
and I2 1.42?
Okay. So answers are varying. So others? Anyone else? Only two people have solved. Others?
Ma'am, I1 6, I2 4.
Okay. Okay. So can you tell me, how did you calculate it? The steps, can you explain?
Ma'am, using KVL in loop 1 and loop 2.
KVL you have applied. Okay. How did you apply the KVL?
And ma'am, I have solved it using KCL.
Okay.
Ma'am,
So here the
should I?
currents are have given means this is somehow related to mesh analysis, right? Right? This current looping as it has given.
Yes, ma'am.
This is kind of mesh analysis, but still it can be solved by KCL, it can be solved by KVL, it can be solved by mesh analysis, it can be solved by nodal analysis, no problem. So tell me how you have solved. So anyone can tell me here. I
Ma'am,
just
can I
write, I
tell
will
with
see.
KCL?
Yeah, Shirish.
Ma'am,
Shrish.
first I have taken like the node below 3 ohm resistor as no below.
This one.
No, below.
Okay, this
Yes,
one.
this one as ground.
Yeah, good. Very good. This is the reference
Then
point. Okay.
there in the left side of 6 ohm resistor there will be 42 volts, and in
Okay.
right side of 4 ohm resistor there will be minus 10 volt.
Good. Very good.
And then I have applied KCL in the node between 6 ohm and 4 ohm resistor.
So here, have you assigned any nodal voltage?
Yes, ma'am, Vx for example. So
Okay, Vx.
I found that voltage to be 6 volts.
Which one?
This
Vx.
Vx after solving.
How did you calculate?
Ma'am, Vx minus 42.6 ohm plus
Vx
Vx
minus 42 over
upon
6.
6, then
Huh?
plus Vx minus 0.3.
That means you are saying current is going here. Then
Yes, ma'am.
Vx
Then minus 0
3.
upon 3. And then Vx minus 10 upon 4. So it will be Vx plus 10 upon 4.
This is minus or plus?
Uh,
Okay, that means you are taking
yes,
this
ma'am. Yes, ma'am. Yes,
current
ma'am. Yes,
directions.
yes, ma'am.
Okay, that means plus Vx minus 10 means plus 10
Plus 10 upon
over
4
4
equals 0.
is equals to 0. Good.
Yes, ma'am.
Then from here you got Vx is
Vx to
equals
be
to
6 volts.
6 volt. Good. Then next, after
Then
getting Vx, I1,
the
how did you
yes, ma'am.
find?
Then for I1, I
Huh?
find 42 minus Vx upon 6 by V equal
42
IR
minus Vx. Very good.
upon 6.
Uh, then how much you are getting? Here 42
Uh,
minus 6 over 6.
so it will
How
be
much you are
6.
getting? 6 ampere. Good. Then next, I2.
I2. And for I2, Vx minus 10 upon 4. So it will be 6 plus 10 upon 4.
So you are getting 42 plus 10.
No, Vx is 6.
Oh, sorry. Yeah. That is, you are getting here 16 over 4.
Yes, sir. So it will
4
be
ampere.
4 amperes.
Good. So, everyone agree with this? So I have not calculated this 6 volt. I don't know. I have to calculate and I have to see. But the thing is that this is, if nothing is given in the question, how to find it out? That is correct. This procedure, any procedure you can take. For example, in this question, it will be mentioned that find out mesh analysis. If it is not the MCQ question, if it will be the uh, pen and paper you have to solve. So it will be mentioned that you have to do the mesh analysis. So we have to see that mesh analysis we are able to do or not, right? So can anyone do the mesh analysis and tell me how to do mesh analysis?
Ma'am, should I tell the equation or
Yeah,
process by
yeah,
process?
yeah. Tell me how you have done analysis. See.
Ma'am, by procedure going clockwise direction, ma'am, here and 42 volts, it will be potential increase plus 42 volt.
Let me take other color so it will be good. Tell me, this is clockwise. Yeah,
Ma'am, then plus 42.
Some
I'll
other
try.
person mic is on.
Okay, plus 42 means you are always taking the outgoing, not in incoming. Outgoing
Ma'am,
positions you are taking
yes,
for.
ma'am. Yes, ma'am.
Okay, no problem. Plus 42
Minus
in
6I1
minus 6 I1. Okay, then
minus 3
minus 3.
bracket
Hmm.
I1 minus I2.
I1 minus I2. Very good. Okay, is equals to 0.
Yes.
Nice.
Ma'am,
Okay.
for second loop,
Hmm. This is the equation 1.
yes,
So second loop
minus 3
minus 3 I2
yes, ma'am. Plus
minus
3 I2.
I1.
Yes, ma'am.
Is it?
Yes, ma'am. Minus 4
Okay.
I2
Minus 4 I2. Okay.
plus 10B.
Plus 10 is equals to 0. Very good. So this is equation 2. Okay. So from here, if you simplify, what is the equation you are getting here?
Ma'am, minus 3 I1.
Yes.
Ma'am, for
Minus
after simplifying equation 1, minus 3 I1 plus
minus
I2.
6 minus 6 I1 minus 3 I1. That means minus 9 I1 you will get here, right?
Ma'am, we will get 3 common.
Okay. So in that way you are saying. Let me write, it will be easy for others to understand. Minus 9 I1, then minus 3 I2 plus 42 is equals to 0. It will be
Ma'am,
there.
plus
So
3
finally you
I2.
are getting it. You are getting finally how much? Minus 3.
I1.
Yeah.
Ma'am, that will be plus I2, ma'am. Plus 3 I2.
Yeah. This is plus 3 I2. Good. Minus 3
Plus
I1
I2
plus I2.
plus 14.
14 is equals to 0. This is my equation 3. Let me write here. So from here, if I simplify, then how much you are getting? This will be minus 3 I2 minus 4 I2 minus 7 I2
Plus 3 I1
plus 3 I1
plus 10.
plus 10 is equals to 0. If you solve this question, equation 3 and 4, you will be getting I1 and I2, right? Can you tell
Yes,
me how much I1 and how much I2?
ma'am. I1 equal to 6, I2 equal to
6 ampere, I2 equals to,
4 ampere.
yeah. So for everyone, you just see the same question we solved in 2 methods. This is nothing but your KCL you have applied or nodal analysis, or we can say that nodal analysis also. Okay. So we have solved in both the way. We got the same answer, 6 ampere, 4 ampere, and here also we got it 6 ampere and 4 ampere. So which way you feel good, you can do. It's better to do it in this way so that this kind of normally people used to do the mistake here only. Okay. So if nothing is given to you, follow this method or that method, then it is better to go for this method. Okay. So if it is asked you to go for particularly mesh analysis, then you have to follow this. Why I'm saying to avoid this? To avoid for this purpose, because usually people used to do the mistake here. Is it clear for everyone? Clear for everyone? Yeah. Can I go ahead with the next question? Okay. This is the question.
Excuse me, ma'am.
Yeah. You can
Ma'am,
ask.
will you please, ma'am, in mesh analysis, will you please explain the sign, how we take a voltage sign and the resistor sign, ma'am, while writing
Yeah.
equation?
Yeah. So see, actually, this is actually your friend how he has done. He always, I told you, no, means any circuit is there. Let me draw this. Uh, this is 42 volt. This is 6 ohm. This is 4 ohm. This is 10 volt. And this is 3 ohm. The currents it is given. This is I1. This is I2. So usually, if how your friend has considered, I told you in the beginning, whenever we were solving the circuits, like either you can take the always whatever the elements you're considering in the circuit, always you can take the incoming or outgoing. He has considered all the elements outgoing. Like for example, this is the outgoing point of this 40 volt. Like plus, if you can follow this way, okay, current comes out from here, current comes out from here, current comes out from here. If current outs from here means enters here, that means this is positive to negative as per the Ohm's law. When it enters means this voltage drops from positive to negative. Okay, so he always considered the outgoing point of all the elements. He has considered this outgoing of this voltage source, outgoing of this resistance, and similarly here also outgoing of this resistance. So that's why his equation is like this. If I consider always incoming as I solve all the questions, here if we are taking the incoming, then minus 42, then here plus 6. Can you say if I'm saying I1 is flowing means this is I1. I1 is the loop current, and this loop current here it flows 6 ohm across. I1 flows through the 6 ohm. So 6 ohm multiplied with I1. Then again it enters here. So it whenever it enters I1 this side from this, and again it enters I2 from this side. But whenever I am doing the loop analysis, I am following this way. That means I have to consider the net current enters in this. Net current enters in this what? I1 minus I2, I can say. Is it clear? So I can write plus, because entering part I am taking, plus 3 I1 net current enters is I1. I2, if I say that, this will be what? Minus I2. This will be minus I2. Is it or not? Then I can write my I1 minus I2. Then is equals to 0. Is it clear to you? This whatever I have written, or shall I repeat?
No, ma'am, it is
Shall I
clear
repeat?
now. No,
Okay.
ma'am, it is
Then
clear.
you can see that this equation and these equations are same. Only the thing is that plus minus are reversed here because I have considered the incoming and he has considered the outgoing. But whenever you are considering, you have to consider only one notation, either outgoing or incoming. You should not take here outgoing, here incoming. Then totally it will be wrong. That's why I said to avoid this mesh analysis. Normally people used to do this mistake. Commonly they used to do. That's why I said you should not be confused. Directly put this way, then it will be good. Is it clear for you, everyone? If you do the practice, then never you will do the mistake, because concept is clear. Here, whatever I have explained, your conceptually you should be clear. Never you should do the mistake, because I have shown this and here this. then by comparing the concept should be clear. Conceptually you should understand, because mathematics how you used to do different way but the answer is same. Similarly you can see here circuit, if you're solving different methods also, answer will come same, never it will be different. Is it clear to everyone?
Yes, ma'am.
Ma'am, I
Okay.
have a doubt there. How do we get
Yeah.
to minus 42? Is it
minus
minus 42?
minus 42 you can see here, if I'm saying this voltage source, just a second. Yeah, so here this source is present, plus minus 42. If I enters to this side, I'm considering always all the element entering point. Okay, so for example this is V6 ohm and plus minus this is V3 ohm. And you may ask me how you are writing this is plus minus, because I am considering, means the loop is saying that your current direction in this way means current enters in this way. And where the current enters means there is no polarity of the resistance, means we should consider as per the Ohm's law. If you have any resistance, Ohm's law says that, like if current enters to this direction I1 through the arc, if it is flowing, then potential difference creates from positive to negative, that is V1, which can be written as V1 is equals to I1 into R. Okay, for example, I don't know anything. I know potential generated plus to minus, but my current flows from this direction. Well, let me tell I2. Then that time, this is just conventionally opposite direction it is flowing, means this I2 is equals to minus I1 I can write, right? So if I want to put here V1 in terms of I2, then I have to write this is V1 is equals to minus I1, I2 R, which is nothing but minus of I1 R is nothing but plus I1 R. Always the convention remains same. Convention never change. Is it clear?
Yes, ma'am. Yes, ma'am. Got it.
So similarly, here if I'm saying plus minus, if I'm considering here, like your friend you have seen here, he has considered always the outgoing for all the element. So that's why he has taken plus 42 minus 6 I1, then minus 3 I1 minus I2. But if I'm considering only the entering point, this is minus 42, because if your battery is here plus to minus, so here you have the plus 42, and here you can say that like ground, if it is there with respect to ground, this is plus 42. If you see ground, if it is not there directly, I can say that 42 volt also here, right? This negative is nothing but giving you minus 42 volt. So I can then connect to the ground. This end minus 42, this end plus 42 it is appearing if battery is there. So if you take any battery, so if you connect your battery, for example, I'm taking this is 42 volt. If you connect your multimeter, if you take multimeter, which is having the voltmeter, which can measure the voltmeter. So this voltmeter positive should be connected to this positive side of this battery, and voltmeter negative should be connected to negative side of this is negative. So then only you can see that across this battery 42 volt is appearing. Otherwise, it will not give you the value. If you have the means like minus 42, if you want to see, then you have to reverse this, then you can see that. Okay, you can see in the practical, if whenever you'll come to the campus, then you can see that by experimentally also how is it. Okay, whenever we are solving the circuit, so that type like whenever we are taking this end will be considered as the minus 42 volt. If we are considering this end will be considered as the plus 42 volt, because battery has two ends, one positive end and other is negative end, right? Is
Okay.
it clear to you?
Yes, yes, ma'am. Yes, ma'am.
Ma'am, I have few questions.
Yeah, you can answer, ask.
First, is the polarity of any battery is fixed. For this example, if we take the 42-volt battery,
Yes,
the
yes,
upper
yes,
bound is fixed.
yes,
So the question is how
yes.
it is. Yeah, it is depend on the human creation or it is a natural based. Suppose I have a
No,
battery of a 6 volt and this upper
if
side is
you,
a positive terminal and lower
you
side is negative terminal.
this is your design. Whenever you are designing the battery, so that time only this battery is created with the plus to minus 5 volt battery. For example, means like you have the 5 volt battery, whatever we are using small batteries, you might have seen on your mouse, you are putting the battery. Okay. And on any of the equipment like a keyboard also, or means like on your watch, means like a wall clock also, you have seen that 2 points will be there. So if you rotate your battery and connect also, it will not work. Have you seen or not? That means you can see that the positive and negative end, if correctly it is not put on that uh, means like space, then the current will not flow. So the battery has design, means developed. Whenever designing you are doing, that will create the potential difference between these two, and is plus minus 5 volt or 15 volt. Or like you have seen in your first lecture also, whenever charger and your battery was there. So means like 25 watt, uh, if we are saying this is the charger of 25 watt, means which is generating 5000 milliampere current with the 5 volt battery. That means this is design specification. If this design specification is not there, it will not generate the 25 watt. So whenever you are designing the material, how to place, how to do all these things are means during the design, it is uh, taken care, that like how it will generate the fiber. Is it clear?
So
Yes, ma'am.
the side of polarity of any battery is depend on the human creation. We can change the
Human creation means a design, means we are designing in the like industry. Yeah, industry.
ultimately, I'm saying it's not natural. We create like this. This side is positive and this side is negative. It is
Yeah,
fixed for a single battery or particular battery.
how, how can you say that it is natural? Means the battery is not naturally come to your picture. It is designed in any of the industry, right?
I'm saying I was saying the same. That was not natural. We create in the such a way that positive terminal is a fixed. Suppose the upper side or lower side, and it is
Yes,
a
yes,
fixed for a
yes,
particular battery.
yes, 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 yes. Okay. So human body is natural. That's why whenever means we are connected to the ground and the human is here. Okay. So that time we used to be like working as like earthing, means the current can flows through us. We are the conductor. That time we are becoming.
Yeah,
That is
ma'am.
human.
I had a one thing
You can say that.
related to that topic. Can I ask?
Yeah, yeah. You can ask.
Current always travel the shortest path.
Yes,
In that circuit, we can see that 3 ohm is connected to the ground directly with the 6 ohm and 3 ohm.
yes,
Then why we
yes.
travel with the 4 ohm?
See, this is the circuit, whatever you are
Ma'am, it is
like we
copy
are
part of
doing here. So to understand the circuit analysis, this circuit has been divided. So you can see that I1 you are getting 6 ampere, and I2 you are getting 4 ampere. So some of the current also flowing here, some of the current is flowing here, means that is this circuit is designed such a way so that like 6 ampere current is flowing through this, and 4 ampere means net current flows in this is 2 ampere,
Okay.
right? This circuit we have designed it.
I think so many
And
times because we know that thing that current always travel from shortest path.
yes, 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 because why, if you see, if I draw this kind of circuit like plus minus, this is 6 volt, and
Yes.
here one resistance is there. So the
Yes.
current will not go here. Here current will be zero. Here it
Because
will go.
short circuited. Yes.
Yes.
Ma'am,
Yes. So
current
this
selects
is
the
correct.
less resistive path rather than the shortest path. It is a less resistive path.
Yeah. Means shortest path means
Less resistive path.
he is saying that only means shortest path means that is less resistance means here resistance is what zero, right?
Yes.
So that's why it used to take the shortest path. That means his meaning is that whatever I understand.
Yes, ma'am. Like that, if we touch the wire when current is flowing, but if we touch, then current uses shortest path to the ground using us, our body.
Yes, 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 yes.
That's why
Because
we
more.
get a shock.
Yes, yes, very good. And what is the importance of the resistance you are getting? So to design the devices such that we will not get the shock, right?
Yes.
So that's why you are studying this kind of circuit analysis and all. If it is
Because
clear, then
current
you can.
complete its loop, then we even we touch that wire, then it is in a continuous flow. That's why we
Mhm.
did not get any shock.
Yes, yes. Okay. So, okay, then let's move to the next question. So this is the next question. You have to compute the current in the 23 ohm resistor using superposition theorem. Superposition you have studied, like superposition principle. If you
Yes,
have
ma'am.
more than one source in the circuit, you have to deactivate one source, activate one other source, and you have to find out the same thing, current across 23. Then at the end, you have to add both the things, right? Can you try by yourself and let me know? So according to you, I will solve here.
Yes,
Yeah.
ma'am.
If we consider
Use the
200 volts, then we had to uh,
yeah. So
open
first
that
consider
20
yes,
ampere.
200 volt. If it is active, then you have to deactivate
Remove
the 20
remove that
ampere.
yes.
De and deactivating the current source means it is open circuit.
Yes. If
Okay,
we consider the
and
20 ampere source, then we had to get short circuit that voltage source.
yes, case one. Then case two will be your
Uh,
200
Equivalent
volt
resistance.
will be deactive,
Yes.
and your 20 ampere is active. Okay, then you have to find out the current through the 23 ampere. So this deactive means open circuit current source. Okay, this deactive means short circuit. Voltage source will be short circuit.
And we had to find the equivalent resistance in both conditions. And
That depends upon how are you solving. That is not
okay.
compulsory. So
Okay.
finally, you have to find out here the current due to the effect of 200 volt and the current due to the effect of 20 ampere. Okay, then final current will be I effect of 200 volt plus I 20 ampere effect. This is nothing but superposition principle. You just tell me the answer.
Ma'am,
Ma'am, because of
Yeah.
200 volt, it is zero because there is no potential.
ma'am, could you please explain what is superposition principle?
Yeah, I'll explain. So you just answer both, then finally I will just do it here. Just find out this final current, then I'll answer. So while answering, I will just explain what is the superposition principle. Okay. If you are not able to do the superposition principle, uh, Mathian, I think you are asking. Okay, can you
Yes.
solve by without using the superposition principle and let me know what is the current across 23 ohm, either KCL, KVL, whatever you are applying? Then it will be good. Both the way we can compare, right?
Okay.
Without using superposition principle, you just find out what is the current flows through this 23 ohm. Anyone got the answer? Nathayan, have you got the answer without using superposition?
No, mom, not yet.
Ma'am,
Okay.
I think the current uh, through when we consider only 200 volt, then the
20
current
ampere.
no,
Ampere.
when we consider only 20 ampere, then
Mm-hmm.
the
We
current
got
will be
1.98 ampere.
10 point
One,
something,
one,
10 to
one by
4.
one, one by one, one by one. Yeah. Can one by one answer because I am not
Yes.
able to hear.
Ma'am, we have to tell you total answer by adding both.
Tell me I 200 volt, how much you got it? I 20 ampere, how
Ma'am,
much you got it?
I
And
got
total, how much you
I-20 ampere. I-20
got?
ampere, I think so. It should be 10.4.
Ampere you got it. And I 200 volt?
That I'm calculating.
Yeah, yeah. Do all the calculation, do it, then I will do it. Yeah. Means he will
Okay,
guide me
ma'am.
and I will do it. How
Okay.
we have done in the previous problem.
Ma'am, I have got I 200 volt is 0 and I 20 is 20 ampere.
Okay, different answers you are getting. Okay. Let's other solve, then we can see here means which is the correct one, right? Mathian is calculating without considering the superposition principle. Then we can means like match all the way which is correct, right?
Yes, ma'am. I
And
could it.
Nitish, can you do one thing without using superposition? Can you calculate, Nitish?
Ma'am,
Yes,
I've
ma'am.
calculated.
Yeah, you just without using superposition principle, can you calculate the current through the 23 ohm?
I did without that one.
Ma'am, I think it should be 12.07 amperes total.
12.07 ampere.
This one. This one.
Nitish, have you calculated current through the 23 ampere ohm is directly without using superposition principle?
Yes, ma'am. I have done without it. I just take the short circuits when we take the case of 200 volt. The 23 ohm resistance will be short circuit because of there is a
No,
plain
no, no.
wire around.
Again, you are confusing. See, whenever you are not considering the superposition principle, means there is no case of the active and deactive case. Means your 200 volt is there, 20 ampere is there without using superposition principle. Are you
Okay,
following
means
me?
both the cases running together.
Yes, yes. Superposition principle means you have two sources. I think Mathayan, you can focus on here. What is superposition principle?
Ah,
You have two sources in the circuit. So, if I want to find out anything in the circuit, for example, here it is asked that you have to find the current flows through the 23 ohm, you have to find by using the superposition principle. What does it mean? That whenever you have the two source, you have to activate one source, means you have to keep this source and other source you have to remove. And if you are removing or deactivating or de-energizing other source, means current source is this one, that current source de-energizing or deactivating is nothing but open circuit. That means this will be open circuit, and now your circuit becomes means in the case of the first, whenever you are taking this case, like if you have considering case one, okay, in the case of 1. So your circuit will be and this will be open circuit. This current source, this will be 4 ohm, this will be 23 ohm, this will be 200 volt, and this is 47 ohm, and this is 27 ohm. So this is the meaning of 20 ampere deactivating means current source, deactivating means open source. Voltage source deactivating means short circuit. Okay, that means case 2 figure will be your
Ma'am, using that superposition,
yes.
first I consider 200 volts, then I find the current is 1.98 amperes, and after considering 20 20 ampere source, then I get a voltage of 2.46.
Voltage of, you have to always calculate this current. Okay, this
Yes.
current is known as your the effect of 200 volt. Whenever it is there, what is the current flows through the 23? When the effect of 20 ampere is there in this circuit, then what is the current across through this 23 ohm? You have to find out. Okay.
Okay. Okay.
Mathian, is it clear what does it mean by superposition? Superposition right now you can say that effect of 200 volt, whatever current it has given, effect of 20 ampere, whatever the current it has given for 23 ohm, or which current is flowing, then total current will be taken as the current flows through the 23 ohm due to the effect of 200 volt, means that means this case, plus the current flows through the 23 ohm because of the effect of 20 ampere. That will be actually the total current flows, means superposition. That's why we are saying superposition means the effect of two sources we have individually calculated. Then the if total current will be the addition of the two currents, whatever we are getting due to the individual effect of the sources. Is it clear, Mathaya?
Yes, ma'am. Yes, ma'am. I have one more doubt here. Can we use KVL or KCL
Yes,
to the circuit which is having
yes,
more than one sources?
yes, you can also do it. KCL, KVL also you can use it.
Oh.
Okay, but sometimes what happens, the circuit will be having multiple sources. That time it will be very difficult to solve. That's
Yeah.
why it will be easy to apply the superposition
Yes,
principle.
ma'am. Thank you, madam. Thank you.
Okay, so can anyone guide me how to find out I 200 volt? So I will just do it here.
Yes, ma'am. First, we find the equivalent resistance 4 and 23, that is 27 in series because of series.
So you
And
just
we,
tell me this case.
200 volt, no, ma'am? Yeah,
This one.
I'm saying for that.
ma'am, 4 ohm and 23 ohm is in series.
Okay,
That is
We get
20.
27 ohm.
27 ohm. Then
And ma'am, we can see that 27 ohm is in parallel with that 27 ohm. Now,
okay, okay,
then we get 54 ohm, and 47 ohm is in series with 54 ohm.
okay.
54 is
Then
27 by 2 because that
so what
those are in
the
parallel.
the method I am just following. I'm not focusing on the uh
Yeah, my mistake, ma'am. We had to consider the parallel, then we had to divide by 2. Yes.
okay. Then after that,
After
Series
that,
with
we can
47.
add 47 plus the equivalent resistance after calculating the parallel 27 27.
my question is that which current is flowing in this? The same current flows at 4 ohm. So if you are combining these two resistors, that's why no problem because same current flows through these two. Is
Because it
it
is
the
in series.
same? Is it same current flows through this 23, 27?
Yes, ma'am, because the 27 on that side and 27 at that side.
No, ma'am,
Mm-hmm.
though because both are then parallel, so current are different.
Yes. Okay. So I cannot apply directly. I cannot take the equivalent circuit and find out the current flows through this 23.
Okay.
If it
But
is,
when
then you have. to rethink about that how to solve.
But the
Is it
current
clear?
should be same because resistance are same.
Resistances are same, that's why currents are same. Good. Okay.
Current divide equally,
So,
ma'am, because
yes.
in parallel.
Okay. Okay. That's
No, ma'am,
correct.
in parallel it divides equally when resistance are same.
Okay.
So,
Resistors is
That is
also
correct.
equal.
That is correct. This current same. But now again you are taking the 27 parallel to 27. So the current you are taking through the equivalent resistance. Is it same across the 23 ohm? Because your objective is to that find out the current through the 23 ohm. Are you following? My objective
what?
is that at the end I have to find my
Yes,
objective is that I
yes,
have
ma'am.
to find the current through the 23 ohm.
Yes, ma'am.
So which way I have to? So anyone can answer?
So ma'am, basically, when we
Up to that I am
when
fine.
like
Up to that I am fine whenever you are saying this is 27 ohm and this is your 27 ohm. So here you have the voltage source plus minus 200 volt and this is your 7
47.
ohm
47.
and this is 27
27.
ohm. And
Yes, ma'am.
what of the current flows through this 27 ohm? Same current also flows
Yes,
through
ma'am.
the 23.
Yes,
So
yes.
I can say that this is like 200 volts.
Yes, ma'am.
Okay. Now I need to find out this current. How to find?
Yes, ma'am.
We had to use the voltage divided, but in parallel, the voltage divide in same, and in series, the voltage did current did not divide. I am
No, that is fine. You are saying whatever the current flows here, the same current flows here. But you are taking it again, you are equivalent resistance. If you take the equivalent resistance,
Yes,
then
ma'am.
that will be different, right?
okay.
Okay.
So, ma'am, we can
Yeah.
do one thing that we can take equivalent resistance of 27 and 27 ohm in parallel,
We
and
can
then
find the voltage across
uh,
4 ohm resistance.
4 ohm, where is it?
4 ohm.
This
Before
is 47.
uh,
This is
ma'am,
47 ohm.
we can do one thing that by taking equivalent resistance of all these three resistors and find
Mm,
the current, and then
mm.
that current we can do half because it will divide equally.
I don't want to do that. How can you say that that is correct or not? It is, see, simple. This circuit is given to you. You cannot apply KCL, KVL, or mesh analysis, loop analysis, whatever, rather than simplifying the circuit.
Mm, okay, ma'am. Yes, ma'am, we can apply that also. Okay, okay, okay.
That
I
you do.
got it.
Why are you going? Because then complexity will increase. I don't know. I may not get the current across through the 23 ohm. So why to go for the complex method? So directly, if this current I am able to calculate, then that will be correct. I can know.
Okay, ma'am.
So I can consider this as ground.
Yes,
yes,
ma'am.
Then you apply KCL or KVL or loop analysis or mesh analysis, whatever you want to apply, and find out. And you also know that whatever the current flows here, the same current should flow here because the resistances are same. Then it is also good to you. So let's consider some Vx or some voltages appearing here. KCL you apply and tell me what will be the value you are getting. Mathayan, can you tell me if I apply KCL here, how much you are getting?
I am trying. I am trying to calculate.
Yeah. Do it.
Ma'am, for first case, I 200 volt, I got 1.74 ampere currents, which is passes across 23 ohmic resistance.
Okay, how do you calculate this
But
step?
and first,
Tell me here.
first I find the equivalent resistance 4 or 23, and then we apply the KCL, which have we already applied in previous question, and then get the potential at Vx. First we find
Hmm?
Vx, and then find the potential difference and divided by the resistance, and then I get the this current
Current.
value.
Yeah. Yeah. Tell me now. The equation I will write whatever you have done.
The equation is x minus 200 by 47.
Vx minus
Yeah, Vx by 47
247.
plus Vx upon 27 twice times, two times,
Okay, Vx over 27. That means you
two
have
times.
considered all the currents are like this. Okay. Plus Vx over 27 is equals
That
to
is equal to
0.
0.
So from this Vx, how much you are getting?
The x value is Vx value 47.22.
2 volt. Then you are getting current I 200 volt effect. You are getting Vx over 27, right?
By 27, yes,
That
ma'am.
is that is giving you
1.74. 1.74.
1.74
74.
ampere. Okay.
Yes.
So I wanted to cross verify with others. Are you getting this answer or not? Can others verify and tell me? Are you getting this or not?
Ma'am, current across.
27 in this circuit. You can see that red color, the circuit is there. Across this
Okay.
27 ohm, whatever the current is flowing, that same current is flowing across the 23 because this 4 ohm and 23 ohm are in series. That means same current flows through the 4 ohm, same current flows through this 23 ohm,
Ma'am,
right?
I got 1.65 MP. Similar kind of.
Uh, have you followed
No, I
this
use that
equation? Yeah, tell
current
me.
divided, ma'am,
Vx
using
should be
that,
44.62, man. Vx should be 44.62.
Okay, means you are getting this calculation difference you are getting, right? Vx
Yes,
minus
ma'am.
200. Let me calculate myself. Okay.
And then current will be 1.65.
Okay. Let me do also with you. So Vx is coming 44.628, that is 63 volt. This answer, whatever, this is coming. This is coming 44.63 volt. And if it is 63 volt, then you have to divide over 27, 1.65 around you are getting. I think Nitish, can you verify your answer?
I'm doing it, and again I find the same values. but right now I'm taking the 3 decimal values. I think it
Can I,
affects.
can I write the thing? Here you are getting, if I take the LCM 47 multiplied 27, you will be getting like this, like Vx minus 200 multiplied with 27, then plus, this will be 2Vx over 27.
Yes, ma'am. I
I
also
can
get
write.
1.65.
Yeah. So it will be 2Vx multiplied with 47. Okay. Is equals to 0, it will come. So finally, you are getting 27Vx plus 94Vx is equals to 5400. Then from this, you will be getting 121Vx is equals to 5400. So from this, you will be getting Vx is equal to 44.632. Nitish, can you check your calculation? Okay, this is fine.
Yes, ma'am, I'm
Okay,
doing.
now, yeah, Nitish, are you saying anything? Mathayan, did you get this answer?
No, ma'am, not yet, ma'am.
So for this circuit, can anyone tell when the 20 ampere is effective, that time what is the current through this 23 ohm? It is easy to do. So all these three you can take equivalent resistors, 27 parallel to 47, series to 4 ohm. Then your current division or something you can apply. But current division I have not told you, but if you know you can apply. Otherwise, you can apply that KCL, KVL, whatever you want.
Yes, ma'am, I have got the same 47.8 after taking the 3 decimal values. Otherwise, I have done with 2 decimal values before.
So you can see that is this equation is same with you. If this equation is same, then it is fine. These values.
Yes, ma'am.
Ma'am,
I
after
think
27 ohm and 47 ohm is in parallel, is equals to 17 ohm. Is in parallel with 23 ohm. Then I get
no, it is not
voltage.
required to do the 23 ohm parallel. I again repeat, your objective is to find out the current through the 23. So I should not take this in the effect of the equivalent resistance. I will just convert this to this circuit. Like this one is 20 ampere. This will be again 23 ohm, because my objective is to find out the current across this, okay, due to the
Yes.
20 ampere effect. So this is the R equivalent. This value will be 27 parallel to 47 series with 4.
Yes.
I think this will give you 27.5 ohm. Just verify. And it is easy to apply if you are taking this is Vx, then Vx over 23 plus Vx over 27.5. If I'm considering this way the currents are going, is equals to 20 ampere. And from this I can find the Vx is how much.
Ma'am, you didn't write the 4 ohmic resistance in the circuit. Where you explaining it in a green color?
Yeah, I have written here. See, 27 parallel to 47. Plus 4 means it is series with 4. Right? Then equivalent resistance you are getting 27.5 ohm. Can you cross check?
Where is the 23 in this equation?
In
Yes,
this
ma'am.
equation?
23.
And
Where is
that will be
23 on the resistance?
21.14.
You're getting 27 multiplied with 47, then divided with 27 plus 47, right? Sorry, 17.14. I have made the
Yes,
mistake here.
ma'am. 17 ohm. If we get parallel with 27 and 47.
That will be your, this one will be 17 point,
17 plus 4, 23. 23 ohm,
yeah,
and that side
20.
and also that side. Uh, both 23 ohm is corrected in a parallel.
So you can say this is 23.15 ohm you are getting.
I only got 23.
Now parallel is not required. Parallel we
Okay.
don't want, because I want
No,
this
ma'am,
20.
I am considering for the ma'am. We can divide that current in a two ways equally. Then we get the 23
So if
because
you
ma'am in
get this
parallel.
equivalent resistance is 23, then it is. But equivalent resistance, you are getting something 0.15 difference, right?
Ma'am, I mean we had 23 resistors in the 23 ohm resistance in this side and also this side. Then we can
Uh-huh.
divide current equally to the both
Yes.
resistors.
Yes. Then you can say that 10 ampere, 10 ampere.
Yes, that I mean.
But I'm saying that calculate in this way how much you are getting. You just check it.
Ma'am, I'm little bit weak in equations. That's why you take that.
Because sometimes what happened, do you know?
Ma'am, there is,
23.15 you are getting.
that day lecture
Some
you
days,
take, ma'am,
yeah,
taken by you.
tell me. Which day?
Recent lecture, ma'am, on a
Oh,
Saturday.
no. Saturday I was not taking. Akalya is
Okay,
I was taking, I
okay.
think. Or some TAs. My session is always on Monday.
Ma'am, my problem is I always solve with that superposition and I did not solve with that Kirchhoff's law, and that's why I'm unable to solve with that equations. And I asked that ma'am, then ma'am give us give me an example with the KVL and KCL, but I did not
Mhm.
practice so much. That's why I can
So why
do
I'm
with that.
saying, like superposition used to take longer time.
Yes,
KCL, KVL will take lesser time. Whenever in the
I
exam
had
you have
some tricks like
25.
how to find the parallel resistance equal, using the calculator.
Here how you are doing this equivalent resistance parallel to 23, then ultimately you will not get the same answer. Here whenever equivalent resistance, whenever you have taken 27 parallel to 47 plus 4, you are getting
Yes,
23.15. So
yes,
here whenever directly you are doing 10 ampere, you may not get the particular 10 ampere. Some 9 point something you may get, or 11 point something you get. So that time
okay,
again, if you have this similar kind of options, then your answer will be wrong.
okay.
Okay, so can you solve this question and tell me Vx is how much? Anyone?
Ma'am, instead of 23.15, it will be 21.15, ma'am.
Okay. Let me do 17 point plus 4. Yes, you are correct. You are correct. So different people are saying I have not verified. Yes, this is actually who has told 21? Who has told? Who has told this 21.5? Alka Kumari. Yes, good. So this is 21.115 we can take, because 148 it is coming home. So this will be again 21.15. Can you solve and tell me what is your Vx value you are getting?
Ma'am, Vx is equal to 220.36.
Very good. Very good. Correct answer. We are getting Vx is equals to 220.364. Now you got the Vx value. That means what is your I 20 ampere? You can Vx over 23. That means is equals to how much? You're getting 9.58
9.58.
ampere. So you got this 9.58 ampere due to the 20 ampere source, and you got 1.6 ampere for 200 volt source. So total current across the 23 ohm will be your this one. Okay, I 20 200 plus 20. So you will be getting 1.65 ampere plus 9.58 ampere. So total current will be 11.23. 11.23 ampere. So this is the final answer. So this same question, I will just suggest you. You try by yourself by using KCL or KVL. And you check the answer is coming same off. Then you can understand that this is the lengthiest method whenever you are going for the superposition. But
Ma'am,
why we used to, yeah, tell me.
as we know that the current prefer the less resistive path, then this 20 ampere current select the path across the 23 only,
Okay, see,
because the left hand side part is a more resistive than the right hand side part.
see here 23 and here 21.1, but we were just cross checking that due to the source what how much current flows through the 23, and due to the source how much current flows through this, but this is the part of the circuit, this is not the whole circuit, right? This is the part of the circuit when we are just looking at the effect of the 20 ampere.
We had to
Are you
add
getting
the
or not?
current through that 200 volts and 20 ampere we get after that final calculation.
Yes, yes. Because we are just cross verifying. Superposition principle means what? If you have the more than one sources, we have to see that effect of the source means what? Whenever only 200 volt is there in the circuit, 20 ampere is not there. What is the current you are getting through the 23? Again, if there is no 200 volt, only 20 ampere, what is the current you are getting through the 23 ampere ohm? Then at the end, you have to see that when those two sources are available in the circuit, what is the current actually flows through this 23? That is nothing but the superposition principle. You are just adding the effect of this voltage source whenever this is present. That time, what is the current? When the effect of 20 ampere present and this is absent, that time, what is the current? So then total effect, whenever you just take into the consideration, that is nothing but known as a superposition principle, and which gives you 11.23 ampere. Now in this circuit, if you apply KCL or KVL or nodal analysis or this mesh analysis, you should get the answer directly 23 ohm. Means you don't take the activating deactivating, both the sources are there. You apply, you take some voltage here uh, Vy and Vx. You may take here Vy, you may take this is Vx, apply the KCL, and you find out what is this current I, then you should get the same answer. Understand?
And KVL and KCL is easier than that.
Yes. But why
Okay.
we are studying this? What is the need of this studying this thing?
To make a
Because
simple
whenever you have
our circuit.
means simple your circuit means this is the small circuit. That's why you if you have 10 sources, 20 sources, that time the analysis will be very complex.
Yes, ma'am. We had to
So
take
that
one
time,
source.
yes. So that's why we are studying this superposition principle.
Okay.
Ma'am, I'm asking for the second case only. In this, there is a current generator. So according to theory, current always select the less resistive path.
Mhm.
Then why not 20 ampere current complete the loop with only 23 resistive ohm? Why they went to
Yeah,
that
ma'am.
side of the left side?
Yeah, that
Okay.
thing I asked in the previous question, that current always travel from the shortest path. Then
Okay.
why did not work here?
Okay. No, it works everywhere. Means what is your question? I understand what you are asking.
Yes,
So the thing is that, like, here you have the 20 ampere source. We are
yes,
just looking at the current flows, which path. I'm not concerned about that. Like, are you getting or not? Means the thing is this, now the source is connected to this resistance and this resistance. If you see,
yes.
these two resistances are also in parallel, we can consider. So
Parallel. Yes, that
equivalent,
is.
yeah, equivalent resistance, whenever you take one resistance, one current source, then you can find out the what is the current. Okay. But whenever you have splitted the resistance, and after splitting, you find that this resistance is 21.15 and this is 23, and you are saying that all the current should flow this 21.15 ohm, no current should flow through the 23 ohm. Is it the correct thing, whatever you are saying, whenever you are comparing the with the short circuit or zero resistive value and less resistive value? Is it the same concept?
Yes, ma'am. I mean that 23 ohm is the lesser resistive path. Why 20
23 ohm
ohm?
is higher resistive. 21.15 is the lower
Less.
resistive part.
Oh, yes, yes, yes. After
Okay.
get the equivalent resistance. Yes.
Okay. And here what we are doing, we are just looking at, due to this 20 ampere ohm, how much current gets means flow through this 23 and how much current gets flow through this. And whenever we found that through this 23 ohm, due to this current, how much ampere flows? 9.58 ampere. And if you calculate here, you will get some more current. Then
Yes.
total current will be means it will be 9.58 means you will get 20 ampere minus 9.58 ampere. That is nearly equals to, you will be getting something 10 point something, okay, ampere. That current is flowing through this 21 ampere, 21 plus 1 5 ohm. That
Okay.
from this you can understand that higher current flows through this 21 ohm and lower current flows through this 23. We
Yes,
cannot
ma'am.
say that totally zero, because why? The resistance still it's there. If it
Yes.
is zero resistive, then it will choose totally zero resistive path.
Yes,
But
ma'am.
some
In Anuradhan sir's video, I watched the week 2 video. Week na
Mhm.
fourth video in Anuradhan sir says that current is directly proportional to the resistance. If
Yes,
resistance is
yes,
lesser, then current is great,
ye-
larger.
yes. This is coming from your Ohm's law. Like whenever
Yes,
you are going for V is equals to IR, so this relationship builds from this only. Current flows through this is I is directly proportional to resistance. That's why you are getting I is equal to proportionality constant. If you do, then you will be getting V over R. V is nothing but we can say that proportionality constant.
yeah.
Okay.
They explain with the power formula P is equals to I square R, in which I is doubled. I square
Yes.
we take.
Yes. That's also correct. So if this concept is clear, definitely whenever I square is there, then definitely the power is also will be increasing with the increase with R, I, right? So here
Ma'am,
similarly, whatever the question he's asking, like if you have the 20 ampere, if you have the two resistors, one is having 21.15 ampere, another one is the 23, sorry, this is not ampere, this is ohm. So that means here the current will be more, okay, and here the
Yes.
current will be less
Yes.
because it is high resistive,
And current
right?
always travel from the shortest path. That's why from shortest resistance it's travel.
See, the current travels through the shortest path, whatever you are saying. If I have the current source, I have the multiple resistances, then definitely current gets divided among all these things. We cannot
Yes.
say this current directly I cannot say that it will choose. If some resistive path
No, ma'am.
here means it also
I
gets
mean
some
is
resistive.
where is the shortest resistance? There always the high current.
Yes, yes, that is
That I
correct.
mean.
That is correct. Wherever you have the resistance is low, then current is high.
High.
And so how
And
resistance and
resistance,
current are directly proportional? Because
now I'm coming to that point.
yes.
And here the current resistance is high means current will be low.
Yes.
So in this aspect, this is satisfying.
This
Okay.
concept in clear, ma'am. In week 2, I did not watch that professor's video properly because I am from previous term, so I did not
Okay.
was. But as today, I watched that video from week 2, lecture 1 to lecture 4. Then I cleared that
Okay.
concept.
Okay.
Yeah, according the charge Q is equals to I by T. Why it is a rate of flow of charge
Okay.
in derivative dq by
Okay.
dt. I is equals.
Okay. Good. So next question is that who is asking how it is directly proportional?
Ma'am, me.
Okay, Shrees. So whenever you have the resistance, so for example, this resistance is there. So if you connect to one of the battery here, okay, and let me say that this is plus 2 minus 5 volt battery is connected here. Okay, due to this battery connection, some current flows through this resistance. When this
Okay,
current
ma'am.
flows through this resistance, due to that, some potential difference created across this resistance, that is nothing but VR. Okay,
Yes,
so
ma'am.
here, this resistance value, whenever it will increase, the current values goes down. Why? The question is that you have conductor, the material if you see, and insulator. For the
Yes, ma'am.
time being, another material I'm not talking, only these two material. In future, you'll study another material, semiconductor also. So this conductor is have why we are saying the current flows through the conductor is higher than the insulator. Can you, if you take wood
Wood.
or
Large
if
resistive
you take
material.
the metal, so this is means what? This is resistance is very high, R is very
Yes,
high,
ma'am.
metal R is very low. That means here, whatever the electrons are there, means or right now I'm not talking in that form also. In future, you will study whatever the material property is there, material property inside the whatever the particles are there, that particles are easily means like allowing the current flows through this. So that's why the resistance is low here. But in this, the material whatever we are using, that material does not allow the flow of the current. That means we can say that resistance is very high.
And so it means both are inversely proportional.
Yes. No, no, not inversely proportional. Means here we are saying
Yes,
that
ma'am.
if your resistance increases,
Yes, ma'am.
uh,
Current
uh,
decreases.
yeah, current decreases. If resistance decreases, current increases.
Increases.
Okay, so if I go for the Ohm's law says about that, like if your voltage and current relationship is there, or resistance relationship is there, or current relationship is there. So let me take it with the current relationship. Voltage and current, they are proportional to each other. Okay.
Okay, ma'am.
So if you're increasing the voltage, current will increase. Then that time, if I take the means like proportionality constant as R, then that will be voltage is multiplied with the I into R will be giving you the Ohm's law. So here, if I take I is equals to V over R. Okay. Oh, I
Okay,
think
ma'am.
here I have written something different. Here 1 by R. I
Yes,
is
ma'am. Yes,
proportional
ma'am.
to
Yes.
1 by R. Yeah, yeah.
Okay.
This is 1 by
That's
R.
why I was
Okay.
confused. Okay.
Yeah, yeah, yeah. No, no, no. that is actually 1 by r. Okay, this is 1 by r. So
Okay, that's why I was
that's why
thinking that how it can be directly.
no. Here by mistake means like he was
Okay.
saying I have written just. Okay.
Okay. Okay.
So in this way, your current increases means resistance decreases. Your current decreases means resistance increases. So
Okay.
voltage
Now
and
understood.
currents are directly proportional. Okay.
Okay. Ma'am. Okay.
Is
Ma'am,
it
Okay.
clear to everyone? Okay. I had actually many questions to solve in today's question. I think 3 questions only we have solved. So you
excuse me,
can
ma'am.
note down this question. Yeah.
Ma'am, will you do 2, 3 questions on RL circuit, ma'am?
RL.
Yes, ma'am.
Okay. RL circuit we can solve in the next class. Already time goes because it will take time. So I will come with the RL circuit. Can you take some complex problem? I'll give it to you.
Ma'am, could you share this slide? It will be easy.
Yeah. I have
Yes, ma'am.
already shared today only. Today only I got the link. So that I have
Ma'am,
shared
on
with
G
you.
space.
Yeah, G space only I have shared today only.
Okay, ma'am.
Because today only I got the link.
So, ma'am, from there we can practice these, and in next session you will
Yeah.
we will discuss.
Yeah. And I will come with more problems with RL and RC. Okay.
Okay, ma'am.
Can you note down this and do it? Or you are saying that I have to just share this slide so that all the problems you can solve by
Yes,
yourself
ma'am.
and we can see. Okay,
Share
Yes,
okay,
that
ma'am.
okay,
slide. We
fine.
will try to solve it. And
Then next class we can discuss about this.
yes,
Okay. Okay, fine. I will
And
just
ma'am,
Ma'am,
share
when will
and
be the discussion of graded assignment this week?
I think TA is doing that. TA is taking on Thursday, I think, your session.
Okay, ma'am.
You have a TA session, right?
Yes, ma'am. Because, ma'am, because last week it was not. Then I think this week, yeah.
because week one graded assignment deadline increases, then TA refused to take that graded assignment solutions.
Okay.
Week
Then I think she will do this week. Okay.
yeah.
Okay, ma'am.
Okay, I will just give this rest of the question as homework. You will do it. I will share this slide with all of you. And next session, I will come with more questions on the your RL and RC circuit so that you can
Okay,
comfortable
ma'am.
Thank you, ma'am.
with that.
excuse
Thank
me,
you,
ma'am.
ma'am.
Okay,
Ma'am, next one
fine.
will be on Monday.
Ma'am, will next Monday be a holiday of Diwali?
Next, I will take on myself on.
Ma'am,
Excuse me, ma'am.
Uh, yeah. Tell me.
Ma'am, ma'am, will you discuss the theoretical concept of week 3, ma'am? Ma'am, I'm having doubt, ma'am.
Week week three actually. Vishal, Friday classes actually. All this session summary used to be discussed by Vishal, right? Vishal sir is discussing or not? He told me that he
ma'am,
has discussed
last
everything. That's why. So on again
ma'am,
coming
last week is
Friday,
not discussed.
okay, I will just inform him. Coming week Friday, he will discuss about the week three summary. Okay.
Last
Okay.
Friday sessions has been delayed and postponed to the Saturday in last
Okay.
and
Saturday,
taken by that ma'am.
Akalya. Okay. Okay. I will just inform Vishal. Again, they will repeat this class on Friday. If it is not, then I will take on Monday. Okay.
So, ma'am, next Monday will there be a holiday of Diwali?
Next Monday is the holiday.
Ma'am, I'm asking because it is Diwali.
Diwali next Monday. I think Monday is not Diwali, 21st and 22nd, right?
No, ma'am, 20 and 21st. Monday is 20,
Yeah, Diwali is
Tuesday
in
is
22nd
21st.
22nd it is Diwali.
and 21st
21st,
also, but
22nd.
Monday is in
21st
20.
is the
Okay, okay.
21st is Choti Diwali and 22nd is the Diwali.
Okay, ma'am.
20th session is there.
Okay, ma'am.
Okay. Okay.
Thank
See
you,
you
ma'am.
all.
Ma'am,
Ma'am,
Thank
Thank you,
you.
ma'am.
Yeah.
will you
please
explain
share
little bit
this. Please share
of
this slide
Yeah.
on the
sinusoidal?
calendar too, as qualified students are not on the G space.
I don't have access of all. I just asked today, then they have shared with me. So calendar means I don't understand.
Actually, in
our
calendar there
calendar,
in calendar you can share the slide PDF in description. There is an option.
you
You,
can
you
link
can
that
told the
PDF
support.
link.
Okay, I will just ask to the team. Then I will upload. Okay.
Yes, ma'am. Yes, ma'am. Qualified students
Okay.
are not on the G space. That's why I am saying.
Okay. 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 Okay.
Thank you, ma'am. Thank you.
Okay. Fine.
Ma'am,
Thank you, ma'am.
Yeah. Tell me.
ma'am, will you explain little bit its sinusoidal signal, ma'am? How the time varying voltage and its equation, ma'am? Not understood that one.
Okay. I will just means consider this in the next session. Okay.
Okay, ma'am.
Yeah. Anything else?
No, ma'am.
Okay. Thank you.
Thank you, ma'am.
When the revision sessions are taken for
Today I
quiz
have taken.
and not for quiz.